Welcome to this explainer. We are diving right into how you can deliver code at absolute lightning speed, completely without sacrificing safety, all using the automated power of Git hooks. Look, if you are operating in an enterprise environment, you know the drill. There is immense pressure to ship faster, but you absolutely cannot afford to break things or let quality slip. So let's explore the exact mechanisms you can use to flawlessly achieve both. But first, ask yourself, what if you could catch a catastrophic code error before it even leaves your laptop? We all know the painful reality of manual code reviews. Honestly, they're slow, they're prone to human error, and sometimes they lead to the absolute nightmare of leaked secrets. Imagine finding out a dev accidentally pushed an active AWS API key to a shared repository. Yikes. It's the classic speed versus safety paradox in modern development. To fix it, we're bringing in Git hooks to act as flawless, automated gatekeepers. So here is our roadmap for today. First, the need for automation, then understanding Git hooks. Next, the first line of defense, followed by server-side integration, and finally, scaling all this up for the enterprise. Starting with part 1, the need for automation. The whole idea of modern workflows is that shifting checks to the left makes finding bugs and enforcing company rules dramatically cheaper and faster. Think about it. Catching a formatting error or a security vulnerability way down the line in a continuous integration pipeline, that usually means waiting 30 minutes for a build to fail, only for the developer to context switch back and fix it days later. A shift-left strategy means you catch that exact same error instantaneously, right on the developer's machine, in maybe 2 seconds. It completely reduces friction, saves a ton of compute resources, and really just skyrockets overall software quality. Moving on to part 2. Understanding Git hooks. You can think of Git hooks as your invisible gatekeepers. They are just standing by every single time you attempt to commit or push code. Under the hood, they're simply scripts that trigger automatically upon specific actions, living quietly right there in your hidden .git/hooks directory. Because they sit natively inside your version control system, they can validate code quality, scan for security flaws, and enforce strict regulatory compliance in the background, totally automatically. The developer doesn't have to remember to run a separate linter. The system just effortlessly handles the whole shebang. It helps to think of this dynamic like a local bouncer versus a vault manager. Client-side hooks, they're your local bouncer. They give you immediate real-time feedback right at your keyboard before anything ever leaves your machine. Server-side hooks, on the other hand, are the vault manager. They represent the final, unbypassable authority living on your central repository. Even if a bad commit manages to somehow sneak past the local bouncer, that vault manager is right there to guarantee no rogue code infects the main code base. Let's map out what this continuous code journey actually looks like, tracing it from a local keystroke all the way up to the final server repository. First, pre-commit checks sanitize the code locally. Second, a commit message hook ensures the metadata and structure of the commit itself are perfectly formatted before it's saved. And finally, step 3 enforces the broader organizational rules when that commit hits the server. It's just a seamless, automated pipeline of verification. All right, part 3, the first line of defense. This is about establishing that absolute first line of defense. We want to prevent bad code, embedded passwords, and active API keys from ever entering the shared codebase. Just consider the blast radius of a bad commit for a second. If a broken build hits a shared server, it could literally stop work for 50 other developers waiting on that branch. But if a threat gets blocked at the local machine, it effectively doesn't exist for the rest of the enterprise. Protecting the local environment is exactly what protects your entire team's momentum. A strong pre-commit hook is basically a multi-layered filter acting right before a commit is allowed to go through. Look at the breadth of these quality gates. It instantly reformats sloppy code to match company style guides, scans your dependencies for known vulnerabilities, and runs rapid, localized unit tests. It completely sanitizes the commit. So by the time the code is officially recorded in the version history, you know for sure it's clean, safe, and highly functional. But I have to give a crucial warning here. Relying on simple keyword scans, like just searching the codebase for the word password, that is a recipe for disaster. Modern development requires highly sophisticated pattern matching. A basic keyword scan is going to completely miss high-entropy strings like randomly generated AWS access keys or Azure tokens. You absolutely have to implement advanced regular expressions to catch those complex patterns and ensure real, robust security locally. Let's move to part 4, server-side integration. Transitioning over to server integrations, let's talk about the commit message hook. This is what guarantees everyone speaks the exact same organizational language. And why does this matter? Well, months from now, when you are tracking down a critical bug in production, a commit message that just says, "fixed it," is entirely useless. This hook verifies the structure of the message itself, making sure it includes required ticket numbers, proper prefixes, and clear descriptions. It keeps your project history clean, readable, and directly tied to your work tracking. Utilizing platforms like Azure DevOps allows for strict, central policy enforcement that individual developers simply cannot bypass. These server-side integrations act as an absolute brick wall. They'll automatically reject any pushes that don't link directly to an active Jira or DevOps work item. They'll block incorrect branching conventions that clutter the repo, and they will automatically trigger necessary build validations. It's your ironclad guarantee of compliance across the entire organization. Finally, Part 5, Scaling for the Enterprise. To guarantee cross-platform compatibility across massive teams, you've got to use the Dynamic Environment Declaration, NVBash. Hard-coding a direct path like /bin/bash is going to instantly break things for developers working on different operating systems, like someone on macOS versus a colleague on Linux. This single, critical line dynamically locates the interpreter no matter what machine it runs on. It completely removes those platform-specific bugs that plague traditional hook deployments and keeps your whole team running smoothly. Scaling requires a really careful strategy. To maintain productivity, you need to distribute your hooks via version control for central deployment, so new hires get them automatically. But keep the human element in mind. If you block developers entirely on day one with a massive wall of new errors, you're going to have a mutiny on your hands. Implement a gradual rollout, warn them first, and only block them later once the culture adapts. And above all, optimize for speed by only processing changed files. If your hook takes 5 minutes to scan unchanged code, devs are just going to find ways to bypass it. So, take a hard look at your own workflow right now. Are your code commits working for you or against you? By shifting left with client-side quality gates and strictly enforcing central rules with server-side policies, you completely eliminate the friction between speed and security. You catch catastrophic errors before they ever leave a laptop, and you keep your main repository pristine. Start small, scale smartly, and turn your version control into an automated fortress. So what vulnerabilities could you be stopping today? Thanks for joining me on this explainer.